Okay, now we're going to be starting, the next two sections are probably going a little bit of the trickiest we're going to do for a while. This one is called Algebraic Proof. And so to start with, we want to talk about what are called properties of equality. And so as you learned back in algebra, you can do anything you want to an equation as long as you do it to both sides. And we never really just explained why, we just kind of show, okay, we need to keep the equation balanced, and so this is what we do. Well, the reason for this is what we use what are called properties of equality. And I'm going to list them here now, then I'm going to go into them into a little bit more depth, so you don't necessarily want to have to write them all out now. You can write them when we get to the definitions of them. But there's the addition property of equality, subtraction property of equality, multiplication property, division property, the reflexive property, which we'll go into that one, symmetric property, transitive property, and the substitution property of equality. So, what are these things? Well, the addition property of equality, and if you'll notice here, we abbreviate that as add prop equal because you don't want to have to write out addition property of equality every time you use it, because you will have to write it out. The addition property of equality says that if A is equal to B, then A plus C equals B plus C. Basically, I can add the same thing to both sides. So, for example, if x minus 2 is equal to 4, then the way we solve this is we're going to add 2 to both sides, which gives me x is equal to 6. So next we have the subtraction property of equality, and notice that the abbreviation for this is SUBTR. Okay, you can't just put SUB because we also have the substitution property. So in order to make sure you're clear, you have to put the TR on the end of this one. So the subtraction property of equality says that if A is equal to B, then A minus C equals B minus C. So again, I can basically subtract the same thing from both sides. So if x plus 7 is equal to 12, subtract 7 from both sides, which means that x is equal to 5. Multiplication property of equality, as you might expect, says that if A is equal to B, then AC equals BC. So I can multiply both sides by the same thing. Now we don't use this one this often, but an example of where we would use that is, let's say I had 1/2 x is equal to 10. Well, I can multiply both sides by 2 to cancel off that 1/2, and that would give me x is equal to 20. Okay, and then the division property of equality. This one we use all the time. So if A is equal to B and C does not equal to 0 because we can't divide by 0, then A divided by C is equal to B divided by C. So, again, if 3x is equal to 12, divide both sides by 3, x is equal to 4. Now the next properties are, you haven't really used these before because well, they seem pretty obvious. The first one is the reflexive property. Now the reflexive property I want you to think about by thinking of looking at yourself in a mirror. What you see is a reflection of yourself. Well, the reflexive property of equality says that A is equal to A. Now that seems kind of obvious, and we actually don't use it that often as a property of equality. We basically have the property of equality so that we can have another property later on that I'll get into next time. But basically anything is equal to itself. That's what it amounts to. The next one is called the symmetric property of equality. Now if you remember what the word symmetry means, this means it's like something that's kind of even on both sides, like a heart or something like that. Well, the symmetric property of equality says that if A is equal to B, then B is equal to A. Essentially, this is the property that lets me flip an equation around. If I want to have my x on the left or want to have my x on the right, this is the property that lets me do that. Next we have the transitive property. And this one looks a little bit complicated, but it's pretty straightforward. If A is equal to B and B is equal to C, then A is equal to C. Okay? We're basically setting up a little chain. So an example I like to use is that if 1 dime is equal to 2 nickels, and 2 nickels are equal to 10 pennies, then 1 dime is equal to 10 pennies. That kind of an idea. Okay, the substitution property of equality says that if A is equal to B, then I can substitute B for A wherever A appears. Okay? So if x is equal to 5, Then, if I've got the equation y equals x plus 2, I can plug in 5 for x and I get y is equal to 7. Now, this isn't really a property of equality, but we kind of group it in here with the properties of equality because we use it quite often in the same situations. But the distributive property, which hopefully you remember, says that a times b plus c is equal to ab plus ac. Okay, so again, whatever's outside the parentheses, you multiply by what's inside the parentheses. And one thing that may not be quite as obvious is it's also true going the other direction. That if I have AB plus AC, I can factor out that A, and I end up with A times B plus C. So, why do we have all these properties? Well, because we want to start constructing what are called proofs. A proof is an argument, essential, or a plan, or a blueprint, however you want to think about this, which uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Okay, we're going to be given something, and we're going to be asked to prove something. That's generally the way a proof works. And so an algebraic proof is a proof which uses algebraic properties. And so generally for a proof, you have to be able to list, okay, this is what I'm stating, and this is what I'm stating, this is the reasons why I can state that. And generally what we use is called a two-column proof, although there's several other types of proofs. We'll get into that again later. But we're going to start off with just a kind of a basic two-column proof. So again, for each step, you have to show the reason why you can say that. You can't just say anything you like to. You have to be able to say a reason why. Now, you can use a definition, you can use a postulate, you can use a property, or you can use a piece of given information, or you can use like a theorem that may have been proved previously. Once you're informed that a theorem is proved, you can use that theorem later on. So let's take a look at how a proof would actually work. So I've got the equation x minus 1 is equal to 5. And we're going to solve the equation and write a justification for each step. So my first step is to write down, okay, what am I starting with? Well, x minus 1 is equal to 5. That's my given. You always want to start out with the things that you know, the things that that you're given as part of the problem. Because that way you have something you can reference back to as you go on in the proof. Well, I mean, if you're looking at this thing as solving this equation, what's the first step you're going to do? Well, you're going to add 1 to both sides. So we'll do that. So we're going to add 1 to both sides, and the property that lets me do that is my addition property of equality. Well, I've got this negative 1 and positive 1, so I'm going to simplify both sides. And I get x is equal to 6, so I'm done. Okay. Let's look at a little bit more complicated one. We've got 4m plus 8 equals negative 12. So again, we're going to solve this and write a justification. So the first thing, I write the equation, tell us it's my given equation, it's what I'm starting with. Well, my first step is I want to get rid of that 8. So I'm going to subtract an 8 from both sides, so that's my subtraction property of equality. Then I'm going to clean it up so I have simplify, so 4m equals negative 20. Divide both sides by 4. That's my division property. Simplify again, and I get m is equal to negative 5. Now, one thing that as you get more, basically what we want to get away from, though, is to get rid of all of these, these simplifies here. Okay, because, I mean, we can look at this equation here and say, okay, I know I have to do the subtraction property. I don't necessarily have to do this step here. So we don't necessarily write out the actions that we use to solve the equation. We just write the result of the action. We kind of clean everything up. So this is how it would work on this equation: 4x equals 2x plus 8. And we're still going to solve the equation and write the justification for each step. We're just going to kind of condense things a little bit. Okay? So, start off with our given equation as usual. You can either say given or given equation. Either way works. So the first way I would want to solve this thing is I would want to what? Subtract the 2x from both sides. Well, that's my subtraction property. Well, once I subtract the 2x from both sides, I'm left with 2x is equal to 8. The biggest hiccup students have when we get to this part is you want to tell me what you're going to do instead of how you got there. Okay? Whenever you're writing these steps, tell me how you got here. Don't tell me what you're going to do. Because, what are we going to do now? We're going to divide both sides by 2. But don't tell me that yet. Okay, let's actually divide both sides by 2. So we get x is equal to 4. And that's my division property. So again, notice each step here tells me what I did. It's not telling me where I'm going. Okay, that's probably the number one mistake I see students make on these algebraic proofs. You're trying to tell me where you're going instead of where you've been. Okay, so try to be aware of that. Okay, now we can also go back to some of the things we looked at in the chapter 1 with the segments and angles and stuff, and we can actually kind of start constructing proofs that use those things. So I've got this segment here, and so we're going to solve for x, and again write a justification for each step. Well, in this case, I could put a statement in here. In fact, I probably should have, but anyway, that says that, well, okay, my is equal to 9x minus 4, ma is equal to 5x plus 7, ay is equal to 2x plus 3, and that's my given information. So I was a little bit lazy here, and I just started off with my segment addition postulate information, which was my is equal to ma plus ay. Okay, again, part plus the part is equal to the whole. And then I can go through and substitute. Okay, I know that my is equal to 9x minus 4, and ma is equal to 5x plus 7, and ay is equal to 2x plus 3, and that's my substitution property. Okay. Now this one I do need to clean up some. So this is actually, I am going to use a simplify here, but that's because, again, we're just tidying things up a little before we actually go into solving the equation. So now what would I do to both sides? Well, I'm going to add 4 to both sides to get rid of that minus 4. And then I'm going to subtract that 7x, and that gives me my 2x equals 14. Again, that's my subtraction property. Notice the TR there. Well, what is my last step going to be? I'm going to divide by 2. That's my division property. Okay. If you ever find yourself with your answer and no way to state how you got there, you might see if you were doing the thing of telling me where you're going instead of where you've been. Double check that you're not doing that, because your last step, you should tell me how did you get that last step. If you can't tell me, then it maybe got lost somewhere. Okay? So we're going to do quite a bit of practice on this, because I think the best way to learn this thing is to do it kind of over and over and over again. So you have that to look forward to when we get to class. So make sure you write your summary for Objective 8. Go back over your notes on that. The more that you go over your notes, the more clearly it's imprinted into your working memory. So it's easier for you to pull it up as you go back over your things. So see you later.